All right, you have 9 problems on these notes. We will do the first 2 together, which means the video comes first, and then you'll see the same problem on a Nearpod slide. I could have just deleted it off the Nearpod slide, but I thought, depending on how you're using the Nearpod slides, you might like to have it. The draw it function is enabled on those slides, and if you have a good input device and you're enjoying doing it that way, that's fine. If you printed it out and you're working on your sheet, that's really good too, maybe even better, probably even better. But I leave it to you to decide how best to take your notes to understand the material and to be able to reference it later when you're studying. So we're doing this one together, we're doing the next one together, and then I'll tell you the plan after that. The directions say find the rate of change. That's the same as finding the slope represented by each line. Some answers are rounded, so when we're looking for our answers down here, some of them may be rounded to specific place values, and we'll be able to figure out which one we're looking for. Cross out the letters above the correct answers and write the remaining letters in the spaces at the bottom to do the riddle part of it, which I really don't care if you do that part, but I do care that you're looking for your answer down below. So let's do this one together. We have distance traveled. So we have distance is our dependent value, and the distance in miles that we traveled is dependent on the dependent variable, which is the time in hours that we've been traveling. And so in 1 hour, it looks like we went a little less than 50 miles. In 2 hours, about 80 miles, etc. And if we want to find the slope, the rate of change is the slope of the line. And we know that slope can be represented as the change in y over the change in x. Now here's the tricky thing about these lines. This would be a bad point to choose. This would be a bad point to choose. The reason those are bad points to choose is because I know what x is, and I can kind of tell what y is, but kind of is not what we're looking for. We're looking for points where we know exactly what x and y both are. And so in this case, 2 very good choices would be this point and this point. In some lines, you'll have more than 2 good choices, and in that case, you pick the 2 you like the most. It doesn't really matter. But you really need to be able to tell what x and y are in order to accurately calculate change in y over change in x. Okay, so let's, if I want to relate it to the homework you did, I could call that point A and point B. You don't have to do that for everyone, but if that's helpful to you, you can. And so if I start at A and I go to B, my change in y is 1, 2, 3, 4. But it's no longer just 4 units. Now it has context. Each unit is 50 miles. So if I go from 0 miles to up to here, I went up 200 miles. The change in y is 200 miles. So we don't want to put positive 4 there. We want to actually take the units off of the graph. And we were moving up, so that's positive. So positive 200 is the change in y. The change in x, I'm moving to the right. I'm going from 0 hours to 5 hours. So positive 5 hours. And 200 divided by 5 is 40. So 40 miles per hour is the rate of change. So if we look down at the bottom, it's right there, 40 miles per hour. So you would just cross this one off lightly. Okay. 40 miles per